Hi friends, welcome back to Edipedia World. Today we will be starting a fresh chapter which is on sound. So sound is kind of a wave, and today's lesson will be focused on the basic ideas behind it, how it is produced and how it is transmitted. Next we will see what is the range of audibility for our human ear, and finally we will conclude today's lesson with some basic understanding about the properties of sound, like its wavelength, frequency, time period, and why it is a longitudinal wave rather than a transverse wave, and things like that. So let's see what today's lesson has for us. In order to begin our discussion, let us understand how sound is produced and how it travels. What happens is that there is a vibrating body, and that vibrating body can be anything from a loudspeaker to our vocal cords. Let's say there is a source here of a vibrating body, and those vibrations are transmitted through a medium. For us it is the air, so the air particles push against each other, and a region of high pressure and consecutively a region of low pressure is formed, and these high pressure low pressure regions alternate, and the high pressure region keeps changing. Once it is here, next it moves here, so this way the pressure gradient keeps traveling throughout this direction. That is, if the source is here, it keeps traveling outwards from the source, right? And that is how the sound waves travel. Okay, and this is the reason that for a sound wave to travel we require a medium, because basically the transmission of sound wave is through formation of high pressure and low pressure regions in the medium. Okay, and this is our waveform of a sound. This is the high pressure region, and then this is the low pressure region. So it is basically a wave like nature, sinusoidal, we call it sinusoidal wave nature. Now that we have seen how exactly the sound is traveling, then this traveling sound will ultimately reach the ear of a person, and in the ear of the person, this vibrating particles of air or the vibrating particles of the medium will cause vibration, which ultimately gets converted to the sensation of sound by the nervous system and by our brain. So is there some restriction to the range of some range in which we can hear sound? As it turns out, there is a restriction, and the restriction is in terms of frequency. Frequency is the number of vibration that the source has per unit second. Okay, so frequency is vibration per second, and for the human ear, the audible range, that is the range of sound which human ear can hear, is between 20 Hertz and 20,000 Hertz. Okay, let me take it. So human can hear from 20 Hertz to 20,000 Hertz, and any sound below 20 Hertz, less than 20 Hertz, is called as infrasonic. And sound more than 20,000 Hertz is called ultrasonic. So both infrasonic and ultrasonic sound is beyond the hearing capability of human ears, but there are some animals which can hear in these ranges too. This range 20 to 20,000 Hertz is termed the range of audibility. Range of audibility. So this is basically the range in which we can hear. Now let us see some of the features or characteristics of a sound wave. Now this is the sound wave which is formed by the source. This is the central region. If there were no sound, then it would have been a flat line like this, but due to the sound there is a variation in the pressure, and this height, the maximum distance from the mean position, is called the amplitude of the sound. Amplitude. Okay. Second is the distance of one complete waveform, that is from here to here or from here to here, is called the wavelength or lambda. So lambda is the wavelength, right? Third, there is a concept that the wave will travel at a certain velocity, right? The wave travels from here to here at a certain velocity v. So what is that velocity v? V velocity can be said to be equal to, frequency is number of vibrations or number of wavelengths per second, and wavelength is itself a distance unit. So the velocity of the sound wave will be frequency, that is number of wavelengths per unit second, multiplied by the wavelength, which is distance per unit wave. So this will give me the velocity of the sound wave, right? Then next is another term which we call time period. Time period, denoted by a capital T, is the amount of time that a wave takes to travel one unit wavelength. Okay, so amount of time a wave takes to travel one unit wavelength. Therefore, if you calculate, time period will turn out to be 1 upon frequency. Why so? Because frequency is number of wavelengths per unit time. Therefore, time period will be reciprocal of that. Okay. So now we understand what is the velocity of a sound wave, what is the frequency, what is the wavelength, and what is the time period. Now let us see what are the properties of sound wave. One, as we have already seen, that sound requires a medium to travel. Okay, and therefore these kind of waves which require a medium to travel are termed as mechanical waves. Mechanical waves. We also know that since there is a continuous change in the pressure of the regions, so basically what is happening is kinetic energy is getting converted to potential energy continuously, and that is transmitted throughout. So this transmission depends on continuous transformation from kinetic to potential and potential to kinetic, and hence it is also, sound wave is also called elastic wave. This is kind of an elastic nature of the medium which helps the sound to transmit from one region to another region. Okay, now one thing to note here is that the sound wave, the compression and the expansion of the air is traveling in the same direction as the direction of the sound, right? The compression and expansion is going from here to here, from here to here, and also the sound is traveling in the same direction. Therefore, such waves in which the direction of motion of the particles and direction of motion of the wave is in the same direction, they are known as longitudinal waves. So sound is a kind of longitudinal wave. Alternatively, what we have discussed about light waves. So light waves, electromagnetic waves, they are transverse waves in which the direction of amplitude is in the other direction. That is, they are perpendicular to the direction of motion of the wave, of the light wave. Okay, so now we understand what are the terminologies that can be used to describe a sound wave. Now let us see some of the properties on which the speed, we have discussed about the speed of sound in the medium, but what are the properties or what are the factors on which the speed of sound depends? The speed of the sound is proportional, this is proportional sign, to root under elastic modulus of the medium and the density of the medium, right? This is the elastic modulus. So higher the elasticity of the medium, more will be the velocity. Higher the density, less will be the velocity. Now you know that the temperature of the surrounding air is not always constant, but during hot days the temperature rises, during cold days the temperature falls. What happens is that with rise in temperature, the density of the air falls. When the density falls, the velocity has to rise, right? So the relation between temperature and velocity is directly proportional. So with rise in temperature, the velocity of sound waves increases. Same is with humidity. With humidity, rise in humidity also, humidity rise will result in a rise in the velocity of the sound wave. So these are some factors which affect the velocity of the sound wave. Okay, so we have seen some properties of sound wave, how the velocity can be changed, and the sound waves also follow the same basic principles which light waves follow. That is, they get reflected, they get refracted, there is some energy loss when there is friction from the surrounding atmosphere, factors like that. But a point of difference is this velocity which we have written here will depend on the material, and the velocity is far less than the velocity of light wave. Normal order of velocity of sound wave in air is approximately 330 meters per second. So this is far less compared to the velocity of light, which was 3 into 10 to the power 8 meter per second. No way comparable. Okay. Second, the wavelength of the sound waves, this wavelength is in the order of, you can say, let me write here, wavelength is in the order of 10 to the power minus 2 to 10 meters. So quite large wavelength. This class has been basically an introduction to the concept of sound and sound waves, and I have introduced you to the basic terminologies and the basic nomenclature behind it. Next class we will start studying about what is known as echoing of sound, which is based on the reflection of sound. We will see some examples of echoing and how the echoing of sound is used to measure the distance between objects. Till next class, have a great day. Goodbye.